Merry Christmas, everyone, and welcome to day 92 of 100 Days of Code. And today we have a special Christmas guest, Jan Andersen. How are you doing?
Ho, ho, ho to all the non-programming characters out there and also to other programming characters. Yeah, I'm having a merry Gitmas so far. I've worked along with the Git and GitHub crash course that you sent me from Academind, and I am a bit more than halfway through. So the most important Git commands are under my tool belt now, and this is what I can present today or repeat today in the code call.
Yeah, let's get started.
All right. So we start basically by setting up the folder that we're working in inside of VS Code, basically making sure that we are not initializing the repository with folders that we don't want to actually include in the init. So that's the mistake I made before. So I had to restructure everything and delete the .git file and stuff, and then basically only open the folder that I'm actually that is actually my root folder of the repository. Yeah, the command that you wrote doesn't work on Windows. That's what ChatGPT said. Unfortunately, the Windows command for that ChatGPT gave me didn't work either. So I had to delete the file manually. Let me check real quick what the Windows command was. Yeah, rmdir/s/q.git didn't do anything. But yeah, and then the .git folder, not the folder with your code inside as well. Yeah, and once you have that, you can open the integrated terminal of VS Code, and I'm having a question on that is already because I was wondering why wasn't Cold not using the integrated terminal. It was it's a much nicer workflow than having it in a separate window. Maybe because he wanted to show that it's a separate program or a separate thing. I don't know. Do you think there's any conscious decision behind that?
Maybe not. Like, could be to not overwhelm the user, right? Because dealing with the terminal when you start out to program is difficult in and of itself alone. So maybe it's just to not overwhelm the user and then learning, hey, you can do all of this also within VS Code is not that much of a leap once you understand how to use the terminal in a separate window.
I actually think it's easier inside of VS Code directly because you don't have to install all the stuff. Otherwise, other than that, there's no real difference so far. But maybe, yeah. but anyway, it's as long as there is no limitations with the one that's integrated. That's basically what I wanted to know as well. If maybe Colt didn't use it because it has some limitations that could stand in my way. But would you say it's a like fully functional terminal, just like the external ones, or
Yes,
are there any?
it's literally the same.
Got it. Yeah. So, and then once you open that, you can actually also open the terminal on specific subfolders as well, with the right in the file tree. And yeah, once you open that, you can git in it, and then or execute git in it, and this basically is your initialization. It creates the .git file or .git folder, and you need that basically as a foundation to use every other command, because otherwise they won't work. Before committing a new snapshot, because Git is all about snapshots of your program, versions basically, you have to add the files that you want to commit. So the command is git add file name or folder name, even though I did not find the correct syntax for adding a folder. Only use dot to add all files in the whole repository, or in the whole root folder, or a project folder is better. And using git ignore to exclude specific files or folders from the add, because if you don't like it's easier to use like a multi-add by adding folder or the full project, because otherwise you would have to type in every single file that you would want to add, and this can easily get very annoying. And yeah, basically git ignore you just create by adding a new file in the root folder of your project, and you just call that file git ignore, and inside of that file you just write the file names that you want to be ignored. And yeah, in my case, I had it all in one folder, so it's I didn't need to check or I didn't get the chance to check if there are any differences between where the files are located, maybe in subfolders of the project. Maybe then you have to also write the file path, not only the file name, but I will see that in the future. And yeah, then once you edit the files, you can git commit, but you have to also commit them with a message, which is basically the same as save as in usual like programs that we use where we save files. I think that's a good parallel or a good metaphor. And you save it with a message by writing git commit -m, and then in quotes you write the message. And for the first commit, you better, or a good message is initial commit. And yeah, you can check different things with git status and git log. Git log is basically a chronological list of your commits inside of the branch that you're in. I'll get into branches in a moment. And the how do I say it? The git status is actually, I don't really know what git status does. What was it again? Maybe some differences.
It shows the state of the current files. So it shows which files are not part of the current commit, which files have changed, and which files or parts of files have already been added to the current commit.
So it basically compares the current commit with the commit before.
It compares what you're about to commit with the last commit.
So after a commit, we can't use git status.
You can, but then there will be nothing because there are no new files, no changes.
Got it.
So it's basically git status tells you when you write git commit, what will be part of that commit.
Got it. Yeah, great. That's great. Yeah, and then you can use git checkout and the commit ID afterwards to basically jump between different commits to check out what's in the commits, and you find the IDs through git log, where you have a chronologically ordered list of the commits. You can also use git checkout to switch between branches, and but that's a moment. And you can use git revert to revert the changes of the commit that you're in towards a certain commit you had before. And this also creates a new commit instead of deleting. No, wait. Instead of it basically creates a new commit that you can then work on, and it's not the same as working in the old commit that you're reverting to. That's the difference as well. And what I actually don't really understand is like the teacher said basically that we if we make any changes that we want to like make any changes in our files, where we then realize, oh, maybe we don't want those changes anymore. Instead of deleting inside of the file, we can just revert to the version where we didn't use it, or where we didn't have the changes. And like, to me, it was like, okay. I mean, if it's a very like easy or let's say if there's not too many changes, then I can imagine being able to keep track of what is in. And yeah, we use these messages to keep track of it, but we like what if you want to change, what if you want to remove everything except for a few things? Like, then it doesn't make sense to go to the Yeah, I mean, I don't know. I guess I don't really have that like that experience yet of how often we do the commits. Um, but yeah, basically what he said was that we don't want to rewrite history, um, but but better revert to history, um, and work from there. Um, yeah. Do you have any? I don't know if I actually had a real question, but do you have any clarifying thoughts on what I said?
I also did not hear the question, but I think the main takeaway here is that the rule of thumb is correct. So reverting to history, basically creating new history that repeats what has happened in the past, is better than rewriting the existing history.
Okay. Yeah. And then we have git reset, which we also use with an ID. And this basically deletes all the commits up to that commit, which basically, but it doesn't include the commit of the ID itself that we insert, right? Yeah, excluding the commit of the ID that we are using. Yes. Yeah, those are the commit, and then we also have some branch commands. Basically, with git branch, we can check what branch we're at. And with git checkout and then the name of the branch, we can switch between branches. And check. Oh yeah, there were like we can create a new branch by writing git branch with a new branch name, with one that doesn't exist. We can create a new branch and then directly switching to the new branch, because with the one that I told you, it just gets created, but you're still staying in the same branch. You can create and switch by with using git checkout -b and then put in the new branch name. And then we also use git branch minus uppercase D, which deletes a branch, basically. Git branch uppercase D, and then the branch name. And with git with git merge, we basically can merge the branch that we're in with another branch that we're writing afterwards, and it really there can be a difference between for example, we are in branch A and we want to merge it with branch B. This can have a different outcome than being in branch B and merging it with branch A, as far as I understand, remember it. But I didn't fully get like what decisions the branches or the merging is based on. Basically, what factors? Like, is it just additions, like adding everything that is new from a certain point to each other, or like does it also work with deletions, and how does it decide which of the two branches if that would be the case, how would it decide which of the two branches deletions are legit? I don't know. It's a bit hard for me to understand how the merging can really be done automatically to really represent what I had in mind when doing that.
It is very hard, and it is a common cause for errors, even amongst experienced developers. And it has to do, like, to answer the question, how does it figure out what to do? It uses the commits, right? So if two branches share all of the same commits, but one branch has one commit more, then you likely know that that is what should get put into the other branch when merging, because one is has just one more new information. But it obviously gets complicated once you involve different branches in different states with different commits. And that's a whole thing in and of itself. Luckily, there's something called rebasing. I don't know if you will cover that in the course, but we are going to look at rebasing, and rebasing basically means you always keep the shared history, and that makes the history linear and very understandable.
Shared history in terms of the history of both branches that you were merging?
Yeah, so basically, let's say we both write a book together, right? Which is a little bit like using Git on a code base. And we first start out, the book has chapter 1, 2, and 3. And now, because we cannot write the same chapter, we say, hey, Leon, why don't you write chapter 4? And I, Elif, I'm going to write chapter 5. And whoever's first done with a chapter puts the chapter into the book, but before the other person would merge, the other person can also now try to put the chapter into the book. With rebasing, that's impossible. So with rebasing, the second person first has to rebase basically their work on all of the existing work, and only then can the other person update the main branch basically with the additional chapter. So let's say you write chapter 4, I write chapter 5, but I'm done before you, so I merge my chapter first. So you have your branch, well, chapter 4, I have my branch, chapter 5, and we have the master or the main branch. The main branch initially contains chapter 1, 2, 3. Then I rebase my changes into the main branch. Now the main branch is chapter 1, 2, 3, 5. And you can now not say, hey, merge my branch or rebase my branch with the main branch. Instead, what you need to do is you need to take the existing main branch and first rebase your own branch on that branch. And while doing that, you're going to probably sort the chapters. So you're going to say, hey, actually, the chapters are 1, 2, 3, 4, 5. And then when you put your branch back into the main branch of the book, then it will get sorted automatically correctly because you did the sorting on your end when you rebased on the existing source of truth. And that way it's always linear what's happening.
I'm thinking if I should ask a deeper question on that, or if that's something for later.
Probably, I mean, you can ask, Phil, why not?
Okay, so if you merge 1, 2, 3, 5, um, how can I? There's still 1, 2, 3 somewhere saved, so I can merge 1, 2, 3 with my 4.
You already have 1, 2, 3 too, right? Because the existing state is 1, 2, 3, and now we both create our branch of the main branch. So in your branch, you start out with 1, 2, 3, and now you're writing 4 additionally, right? So both of us have 1, 2, 3, and I start out with 1, 2, 3, but I'm writing chapter 5. So I have 1, 2, 3, 5.
Okay, and if when I merged 1, 2, 3, and 4, um, how do I merge 5 to it? Do I have access to 5 as well somewhere?
Let's look at this visualization real quick. Let me share this. So this is the stuff that we looked at a couple of weeks ago. Let's delete all of that. This. So let's start. We have the thing here with chapter 1, 2, and 3, like this 3, 2, 1. So and now you're here, then and behind here, and we're both working on this book. So we both start from the same source of truth. So let me grab all of this. Come on, so you start with this, and I start with this. Now you write chapter 4 in there, chapter 4, and I write my chapter 5. Well, chapter 5. So now let's say I'm done before you. So I'm going to like this is this is the main branch. Well, I'm going to I'm just done with, like if you're done first, it's super easy, right? Because you just put your stuff in here, and then this is the new source of truth. But for to make it a little bit more complicated, let's say I merge first. So or basically rebase first. So now this is on top of here. Obviously it's still in my thing too. Oops. Come on. Where's my working? Well, well, this is the sort of truth. Now you're like, hey, I'm also done with my chapter 4. But before you can squeeze this in here, you first need to get back all of the source of truth. So you're actually going to rebase first in this direction. So basically, you're getting this new chapter, and while rebasing, you're going to say, actually, well, the chapter comes after my chapter 4 here. In code, the conflicts look a little bit different. Right? Maybe we should have used code examples for them. That would have made more sense. But let's stick with it for now. So you were starting with stuff. Chapter 5 obviously still exists on the main one. And now, when you put the stuff back, it already linear, so it's already sorted in the correct way. So when you're rebasing, I grab all of these right here. Well, this is just going to get with what you had because it's already correct. And that way it's always linear and everyone always has the same history.
So by accessing the main branch with your new merge, I have basically both the old data and the new data, and then I basically sort it in my branch, and as soon as my branch is sorted, I merge it with the main branch.
Pretty much, yeah. That's kind of obviously in the real world it's different, right? I think the numbers can be a little bit confusing. Let's just do this example one more time without numbers, because that makes it even more obvious. So let's say we start out both with an app, but maybe have a bunch of features here. Let's say it has a login, it has registration, right, and it has a logout. So we both start with this, I have this, And now you create maybe, I don't know, like a notes feature, you create a note taking feature, and I create a feature to allow memberships. And like members. Like when I now merge my stuff first, about a lot more like you see how it's easier now because you can say, hey, this node stuff and this member stuff, it can be related, but since you were able to develop it without you knowing about the membership stuff, maybe it's completely independent, right? So now taking this, taking your nodes basically, and rebasing from the existing stuff is super obvious because you just take the existing stuff like this, and you put your nodes on it. Oh, with the review. And it is that the new code because it's independent. So it's a lot easier to in the real world the conflicts are usually a lot easier or let's just say different than what the chronological example that we looked at previously might suggest.
Okay, so but if the member section would make needs the nodes before, then cannot as dependency or then we would then I would have to rebase it in the other way around, or
Well, the thing here is in the real world, if the second feature depends on the first, then you likely cannot start work on it, right?
yes.
So
Well,
that's how conflicts in the real world are often prevented.
well, how do we like? How can we get any conflicts then? If we don't do
Well,
that,
let's
because
say
otherwise, how why would the orders matter then?
we have some components here, right? Like a card component, like you've a little bit lifted like cars. This, oops, like this. I'm gonna replace this here with common history. We're gonna start from scratch again. Move, like this. And now try for the membership feature, add something different to the card when you do. Right? I create the member feature, you create the notes feature, but we make different changes to the card. Could be I just add special code that I only need from a membership feature, and you add special code for your notes feature, but this is normally like components card with member tree. Right? And now I put my I merge first, so we put all of this here, like this, like this, like this, like here. And you have your component card with the nodes tree, like this. Oops. And now there's a conflict here, right? Because this is not the
Yeah.
same. So when you rebase from main, you need to make this components card with nodes and member tree. Basically, get the members in like this, and then you can make your stuff the new uh, source of truth. Like, oops, with all of this. Come on. This. Grab everything. Mm. And that's how
Okay.
you can get conflicts.
Yeah. 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 I mean, in abstract theory, it makes sense, but I guess it makes sense to just um, go into action from here and experience it in real life to get a
Yes.
better understanding. All right, yeah. That's it with the branches as well, and then the rest was basically setting up GitHub, connection to GitHub, which is not that interesting to um, to explain. And maybe what's a little note is that you can start your repository locally with Git, and then push it to your repository, so you don't have to start in GitHub directly. Yes, but other than that, I think it makes sense to keep that, keep the rest with the GitHub, with the rest of the GitHub stuff for tomorrow then.
Awesome. Then thanks for sharing all of this Git knowledge. And we wish everyone happy holidays and a Merry Christmas, a Merry Gitness. This has been day 92 of 100 Days of Code with
Git and Leon Andersen and my mentor.
Alice Miller from Quack Hub.
And
Thank you, everyone. See you tomorrow.
See you tomorrow.